Hello everyone, myself Dr. V. Thrimurthulu, professor in CSC department, MLR IT, and today's topic is iterative deepening A-star algorithm in artificial intelligence. The subject is, and in this I am going to cover what is that iterative deepening A-star algorithm, what are the key components in that, what is the algorithm, how it is workflow, what is the heuristic function for that, and what is the that algorithm, what it is, the flow, and example, one of the example I will discuss, then advantages, disadvantages, then applications. Then what is that A star algorithm? It is the advancement of the A star IDA algorithm. So it is the one of the variant of the depth first search algorithm, and it is the advancement of the A star algorithm that iteratively deepens its search by incrementing the cost threshold. We are using the threshold value like a depth first search. There is the limitations are there, boundaries are there. Like this here also, iterations limitation is there, deepening its search by incrementing the cost threshold, which controls the depth of the exploration, how much depth you have to go it. The limitation is there in this IDA iterative deepening A star algorithm. Unlike A star, which explores all possible nodes within the threshold, IDA uses a heuristic function to evaluate and prioritize the most promising node, whatever the least node that you are taking. And this allows it to prune less promising paths, reducing memory usage while ensuring that search focuses and optimal routes. The complexity is reducing. You are not exploring all the nodes as A star algorithm. You are exploring nodes, all the nodes. Here is the limitation is there, how much depth you have to go each. Then what are the key features in A star IDA algorithm? It is also graph transversal algorithm. Explores a graph by progressively deepening the search depth. And it is the shortest path finding. It efficiently finds the shortest path in a weighted graph using a combination of DFS, depth first search, and A star, both the combination. DFS and A star algorithm, both the combinations of this IDA algorithm. Iterative deepening A star algorithm, nothing but these two combinations. And advisable heuristic, because the heuristic function is should be always whatever the estimated cost should be equal to the actual cost. That is the advisable function. Ensures that the estimated cost never exceeds the actual cost, making it an advisable heuristic. That is important in these cases. Memory efficiency, as a depth first search algorithm, IDA uses for less memory. In IDA depth first search, you are using the less memory. Okay, as compared to this one, this is the very less algorithm, depth first search algorithm. So this advantage you are taking in IDA. Focused search. The algorithm is designed to explore only the most promising nodes only, most relevant nodes only you are exploring, ensuring it doesn't go to unnecessary depths. That is the advantage in these cases. So how ADA is the advisability function is important. The heuristic function, it should be advisability, and advisability means whatever the cost estimation, it should not greater than the actual cost. That is the advisability. Okay, so works incrementally increasing the threshold based on the F score of each node, which is calculated using the formula. Here F score is very important. That F score depending on the threshold heuristic function. So this heuristic function nothing but actual cost was estimated cost. H is the advisable values and the advisable value. What is that evaluation function? G of n you know actual cost. H of n is the heuristic estimated cost. Then coming to the one of the important thing is the F score is the important parameter in this. So F score is a heuristic function that is used to estimate the cost of reaching the goal state from a given state to goal state, how much depth you have to go. That it is defining this F score. It is a combination of two other heuristic functions, H of n and G of n and H of n. It is used to determine the order in which the algorithm expands. How we are expanding the algorithm now. Child nodes it is showing in the search tree, and thus it plays an important role in how quickly the algorithm finds a solution. And the most promising nodes only are exploring in this case. A lower F score indicates that a node is closer to the goal state, and it be expanded before the node with the higher F score. Simply it is the nothing but g of n, the F score also depending on the this g of n plus h of n. Then step by step procedure for this one. Starting you have to initialize the thing. Initialization is important. Set the root node at the current node as compare its F score based on the F score. Set the root node as a current node and compute its F score. Calculate the F score. Set threshold value. Set the threshold value. How much you have to threshold value you can keep it. Based on the threshold value, you are exploring further. Initialize the threshold based on the F score of the starting node. Node expansion. Expand the current node's children and calculate their F scores again. Can expand. When you are expanding, you can calculate the F score what it is. Pruning. You are cutting nothing but. If the F score exceeds the threshold value, you can prune it. Prune the node and store it for the future exploration purpose. You can keep it aside. Then path return. Once the goal node is found, return the path. You can reconstruct the path. Return the path from the start node to goal node what it is. How we are exploring. What is the shortest path. So update the threshold value. If the goal is not found, then increase the threshold value based on the minimum pruned value and repeat the process. This process again repeating and increase the threshold value. Then you can further expand, explore. Then this is the one of the example it is showing here. ID algorithm. N below the number of trees are there in this. The F score is written inside the nodes. F score what it is the value. Every node you have a F score is there. How much like this F scores are there, and F score is already computed, and the start node is 2 whereas the goal node is 15. Here we have starting here. This is the starting node. Its value is 2, and the goal node here you have to reach. Okay, 15th node, that is the goal node. You have to reach it. Explore node is colored here. You clearly have explore what you are going to explore, because starting node is the root node, that is the you are considered as the current node. Then we are expanding that one further, that node. That's why the green mark it is showing the what you are expanding. The red mark it is showing the where you have to reach. Then root node, this is the iteration 1. Root node is the current node 2. This one. Threshold value, the current node value, threshold value, whatever the value is there here, that is the threshold value 2 based on this one. And we are going to visit. When you are expanding this node, it has a 2 nodes is there. One is the 4th and 5th visited nodes. These 2 nodes we are visiting. Okay. Then again next iteration you can threshold value, because threshold value initially it is the 2. You are not reached the goal node. Again further you can expand it based on the current nodes. The F score value it is changing. Threshold value also it is changing. Here see. Threshold is the current value, node is the 2. So explore child. When you are exploring what it is the 4 is there, 5 is there. It is the less than the threshold values. So iteration is over. That iteration is closed. And the pruned values are here. What are the values we are closed? Pruned temporarily. 4 and 5 we are pruning. 4 and 5 we are pruning those values, because it is greater than the threshold value. Then next iteration what it is. So we are defining the threshold, new threshold value 4, because here 4 is there, 5 is there. 4 is the least one. So least one, that is the threshold value 4. Now based on the 4 threshold value, whatever the nodes are there, connecting nodes, you can expand it. Related to 4, whatever the child nodes are there, you can expand it. See here current node 2 and threshold. So the exploration child, that but so first children 4 here, 2 the first children 4. So set current node is the 4 equal to the threshold value 4. Then explored its child for that for 5, so that is the greater than the threshold value. Okay, threshold value having 5 threshold, so pruned it and explored second child 4, because initially 2 nodes related to that one. So for the threshold value you are keeping this one, so this is the 4th threshold value. When you are considering this one, it is the greater than the threshold value, you are pruning that one. Now we are considering this one for further expanding. See, threshold value, when this expanding, what it is, we are again we are visiting the year, this time 5th node, and this is the 4 value, that also, because threshold value 4, again you can same you are expanding further. So threshold value less than the threshold value, you can expand it. So when you are expanding this one, 8 and 7. Now what are the nodes we are visiting at this iteration? 5, 5, 8, 7, these nodes we are visiting nodes. Out of this one, what it is, the threshold value, all these are the greater. So that again you have to redefine the threshold value. Okay, redefine the threshold values. See, similarly explore the second child node 2, that is current node, it is greater than that one, so that you are not expanding this node, you are not expanding, you are keeping in pruned list, pruned it. So our pruned values again, now it is the 5 is there, 8 and all these values are here listed, and you are keeping in the pruned list, means you are skipping those things. Then iteration 3. See, when iteration 3, what it is, according to that one, previously you have visited these 3 nodes. Okay, when you are visiting these 3 nodes, you are keeping in pruned. Out of this, which one is the least one, that you are keeping as the threshold value. So that 5 is the least one, so that you are keep the 5 as the threshold value. Then based on the 5, further you are expanding the things. When you are expanding for 5, what it is, you are visiting the 7th node and 8th node. Previously this already you have pruned, and here also 5 is there, here also 5 is there. Again previously you have pruned in iteration 1, now again reconsidering that one, so that further you are expanding this one also. When you are expanding this one and this one, so what it is, 1, 2, 3, 4 places you have visited, 4 places you have visited, because 5 is there, same 5, whatever the 5 is, 5 is the threshold value is there, those things we are expanding. When you are expanding 7, 8, 6, 7, 8, both are 6, so that's why single value you are keeping. So 7, 8, 6, all these things nodes you have listed, and you are keeping in the pruned list, you are keeping in the pruned. Again 7, 8, 6 also you are keeping in pruned. Pruned values are 7, 8, 6, because all these are the greater than the threshold values, greater than the 5, so that you are keeping in the pruned list. Then iteration 4. When iteration 4, what it is, previously we have visited those nodes, now we can out of that one, which one is the least node. So 6 is there, we are keeping the threshold 6. Now this time what it is, we are expanding the, wherever the 6 is there, those nodes we are expanding further. See, 6 is here, so you are expanding. When you are expanding, these are the nodes, again 6 is there, that's why same iteration you are expanding these nodes also. And here what it is, here also 6 is there, here also 6 is there. Then you can compare all the 6 are you are exploring here, all the 6 related nodes, child that you are expanding further. When you are expanding further, what it is, you have reached this one, you have visited 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 this one, all these nodes you have visited. So that what are the nodes you are visiting, 7, 8, 9, 13, 7, 8, 9, because 7, 7 is there, that's why one time you are keeping 7, 8, 9, 13, all these nodes you have visited. When you are comparing with the threshold value 6, it is the greater than the threshold value. When it is the greater than the threshold value, what it is, we are keeping in a pruned list. All these values are you are keeping in a pruned list. So these are the values you are going to keep it pruned. Then again iteration 5, we have to define the new threshold value. So now it is the iteration 5, we are defining the new threshold value. Out of the previous pruned list, what it is, which one is the least, 7 is the least in that. So that now 7 is there, threshold value. Least one is the 7, so that 7 you are keeping as the threshold value. In this 7, again you are expanding the further 7. See, here 7 is there. You are expanding these two nodes. You are expanding 7. Here also 7 is there. You are expanding 7. Then here also 7 is there. You are expanding 7. You are expanding 7. Okay. So when you are expanding the 7, you are visited 12, 14, 13, 8, then 14. Or 14 already it is there. And these are the nodes you are visited in this. 8, 9, as per the order, 8, 8 is the 8, 9, 14, all these nodes we are visited. All these nodes we are visited. When you are visiting, what it is, when you are comparing with the threshold, all these are the greater than the threshold value. If you greater than the threshold values means what it is, you have to keep it in pruned. All these nodes we are keeping in a again pruned list. We are keeping the pruned list. We are not reaching the check it whether you have reached the goal node. No, we are not reached the goal node. Our goal node is the 50. So that you have not reached the goal node. So that again what it is, you have to keep it all visiting nodes into pruned list. Then next iteration again redefine the threshold value based on the F score. Based on the F score. See here, based on the F score, new threshold value you are defining. So 8 is the now out of that previous pruned list. There is the 8 is there, that is the least one. So that 8 you are keeping as a threshold value now. Then again, wherever the S is there, child nodes, you can one by one, you can expand it. When you are expanding, you check it whether you have a goal node or not. You are not a goal node. Next 8 is there. Again, you can check it. You are expanded 12 and it is the 9. So it is not a goal node. Then here 8 is there. Then 8 is there. This is the goal. 15. This is the goal node. You have reached. If this iteration 6, you have reached the goal node. Okay, you have reached the goal node. See what are the nodes you have visited in this iteration 6 based on the threshold value 8. You have visited the 12, you have visited the 16, 15, then you have visited 12, 9, then you have visited the 15. These are the nodes you have visited. When you have visited these nodes, 15 is our goal node. In this list it is there. In this list goal node is there. So that you have reached the goal node. So you have whatever the remaining all are, you have kept in the pruned list. You already reached the goal node. Then reconstruct that one. Reconstruct that one based on the node. How you have to reach this one. So this is the path. Then this is the path. Then this is the path. Then this. Then that is the only. That is the only. So this is the path. See here, 2 to 5, 2 to 5, then 5 to 6, 6 to 8, 8 to 15. This is the path, shortest path. Out of that one, that is the shortest path we have reached. 2 to 5, 5 to 6, 6 to 8, 8 to 15. That is the shortest path we found. So that IDA algorithm, it is the one of the optimal algorithm. Definitely you are getting the shortest path. And we are not visited all the nodes. So here you can see the advantages of the iterative deepening A-star algorithm. So optimal path finding. So IDA guarantees the finding the optimal path as it never estimates the cost to the goal. Okay, you are not estimating the cost, you are not calculating based on the F value only. That one. Memory, it is the memory efficient. It uses limited memory only because all the nodes you are not keeping in the open list. So that what happens here, as the A-star algorithm, you have kept the open list, and if it is visited means you are keeping in the closed list. It is not like this. You are in the pruned list only. Pruned list you are not storing. Memory efficient, limited memory compared to A-star by applying the depth first search technique, and every time you add threshold values you are keeping. Advisable heuristics. Heuristic function, based on the heuristic function ensures that the algorithm remains advisable. Thus you are getting, so that you are getting the optimizing performance, optimal path you are getting, so that performance is good and efficient with large state spaces. IDA handles large graphs efficiently by pruning unnecessary nodes. Unnecessary nodes you are cutting down. Pruning nothing but a cutting the things so that we are efficiently getting the goal path, optimal path we are getting. What are the disadvantages in this case? Repeated node exploration, because here what it is, we are kept in the prone list, again we are revisiting. That is the drawback in this case. Whatever the prone list, again we are reconsidering the same node, already visited node we are reconsidering. The algorithm does not store visited nodes, leading to repeated explorations. Slower than A star algorithm, but it is slower than the A star algorithm, but optimal path we are getting, that is the advantage. IDA can be slower than the algorithms like A star due to the repeated exploration of the nodes. Higher computational cost as compared to A star algorithm, it is some more higher cost, but we are getting the optimal path, that is the advantage. So these are the disadvantages in this iterative deepening A star algorithm. So then coming to the what are the applications? These are the applications of the A star algorithm, iterative defining A star algorithm. Pathfinding game purpose, you can use it this one, where memory is not a constraint. So an optimal path need to be found efficiently, such as real-time strategy games purpose, you can use it this IDA algorithm. Robot navigation purpose, applied efficiently navigate through complex environments without requiring excessive memory, so that robot navigation purpose you can use it. Puzzle game solving, puzzle solving purpose in AI applications, you can use it. 8 puzzle or 15 puzzle can be solved using the IDA algorithm. So artificial general intelligence purpose, this IDA algorithm is very much useful in research areas exploring where problem solving often involves navigating vast search spaces, large search spaces purpose, you can use it IDA algorithm. IDA can be used to manage memory while finding optimal solutions. So in all these are the applications of the iterative deepening A star algorithm. And today's video I covered what it is iterative deepening A star algorithm, what are the key components, what are the algorithm workflow, what is the importance of heuristic function, and what is the algorithm. So example also with different many iterations, so how we are getting the shortest path we have discussed, what are the advantages and disadvantages also we have discussed, and applications of the IDA algorithm. And queries, if anything, please mail me. And coming to the our next video, I am going to cover RBFS algorithm, its principles, algorithm flow, advantages, disadvantages, and applications. Thank you, one and all.